Right. So the plan of attack. I want to do the whole of algebra with you guys. I want to give you all a little introduction to functions. Little introduction to it, and then I want to do coordinate geometry. Alright, so Gavita, when you hear the word algebra, your face is twist up?
Yeah, a little bit.
I know that, you know. Katie, that's happened to you too? Or?
No, I like algebra.
Okay, cool. Then you could be my algebra, right? Fiona. Well, I'll just say algesis. That's somewhere. That's some. The algebra joke was better. But anyways,
Yeah.
Gavita, algebra is very simple. What if I told you algebra always existed? Like letters and maths always existed. You'd look at me like, why? Why do we need that? And
Yeah.
right. Let me give you a scenario. So let me just say you go in the store and you buy 5 apples, right? You with me, you buy 5 apples.
Sorry. Yeah.
I thought you didn't like apples, he was just being quiet. Um you hearing me? I'm breaking up or anything, or you all hearing me good?
I know
Yeah,
good.
you're good.
Right, so Kavita, you go into a store and you buy 5 apples. How much you think an apple this cost?
I don't know, probably like $12.
$12. So one apple? One apple?
I don't know how to go shop with my parents.
You gotta go shopping with your parents. Because somebody go sell your apple for $12 and they go buy it and they go rob you. Don't do that. Let me just say it costs $6. So here's the thing, right? Here's the scenario. Oh no, I'm trying you like a boy. I'm trying. No, God. Next thing I'll come beat me. Right, let me just say this is you. And you go into a store and you buy 5 apples. And let me just say the apples costed $30, right? Gavita, in your head, how would you work out for one apple?
I'll divide it.
You divide what?
The
Explain.
30 divided by 5.
30 divided by 5. What if I tell you that was algebra? You just did algebra. You know that's algebra, right?
Yeah.
Right. I was hard. That was hard or that was easy?
It was easy.
Right, so let's look at a couple of scenarios. I don't just wait to pass months away to like for my appreciation for it and like fully understand the thing. Right, so this is the first scenario. Gavita goes into a store. And buys what is the cost for one? Right, so Gavita, like you just said, you would just do 30 divided by 5 and done, right?
Yeah.
Good. What if I told you we could make an equation? Would you believe me? Do you think you know what?
Yeah.
Do you think you know what the equation would look like?
Kinda. Yeah.
Tell me. Take a chance.
5x equals like $30.
Yes. So, if you want, you could let an apple be equal to x. But I'll go even less advanced and I'll just call it a for now. Right? You with me? So In algebra, Katie, in algebra, there's going to be things you don't know. You call that an unknown. Does everybody understand that? If you don't know something, you call it an unknown.
Yes, sir.
Kavita, you know that?
Yes, sir.
Right. So what am I going to call A? A is a what? What's A?
A unknown figure. What,
Right.
apples?
It's an unknown. It's an unknown, right? That's what it is. It's an unknown. However, we know that 5 apples cost $30. So 5 apples equals to $30. So what do we call this? What do you call that? There's a what in the middle? Tell Margarita. I promise I'm not trying to trick you.
I equals
Right. So I'm setting up a what? What do you call that?
a equation.
Yes. Once there's an equal sign in the middle, it's a, say it again.
Equation.
Good. If there isn't an equal sign, then it's a, do you all know what to call that? Like if
Statement.
nah, that's not the proper term I'm looking for. Like if you just see something like 5A, we'll call that Kitty. If you just see something like 5A, what's that? Say that again.
I have no idea.
Okay. You would call that an expression. An expression.
Right. Looking for an E word, but that was, oh my god.
Yeah, yeah. So that's an expression, right? Cool. So I want to make a little notes before I move on. So Kavita, like this is the first time you learn about math vibes, or you're used to watching your YouTube channel.
The first time I learned about it.
Okay, well, you're probably not accustomed to the way I teach. I don't really teach by the textbook. The way I teach is heavily dependent on who I'm teaching. So you guys, and it's like we're going to go on like a Dora the Explorer journey all over. Alright, so learning something might take us somewhere else, but we're gonna go all over. I'm gonna see what y'all don't understand, try to cover that, then move on. So just expect that I'm not gonna teach from the book and go in like a specific order. Alright? And well, Katie, I think it should be a Katie now about my YouTube channel, and she used to watch my YouTube channel, my lives.
Yeah.
Yeah, so you know where I should go. Alright, so you'll need to know the basics and expression. So this is just a mathematics, this is just a combination. This is literally a combination. A combination of numbers. What's another name for numbers in maths? Does anybody know? What's another name for numbers in maths? Does anybody know? What's another name for numbers?
Well, I think no.
Kavita, does the value of a number ever change? Like, okay, Kavita, if I put on 5 there, does that ever change?
Yeah.
Nah, that'll change. No.
Change?
You're probably wondering, what would this man mean when he said change, boy? And you just learn about substitution? Kavita and
Yeah.
Kitty, you'll just learn about substitution. Why just doing that? What do you do in substitution?
Make a big equation smaller.
Make a big... You mean simplification? That's simplification. But in substitution, you would let the variable be equal to some number. So like, let me explain. If I tell you okay, so if I had x plus 3, if x plus 3 was the expression I had, and I tell you that x is 2, right? Then this would now become what? If I substitute x is equal to 2 into it, that means anywhere I see x, I'm gonna write. Anywhere I see x, I'm gonna write
2.
Kavita, what more no?
Yeah.
So this will now become 2 plus 3. Gavita, if I tell you that x is 7, what would it become?
10.
7 plus 3, 10. So Gavita, is the value for x changing or is it remaining the same?
It remaining the same.
Nah, I think it's changing. Over here, I say it was 2. Over here, I say it was 7. You sure I remaining the same?
No, it's changing because it's different equal to different numbers.
Exactly, like, okay, if I told you that x was equal to 9, instead of me writing x plus 3, what would I write? What would I write? Don't overthink it, else. I promise it real simple. Promise.
X plus 6?
Nah. So the expression is x plus 3. And I'm telling you that x is equal to what?
9.
Right. So that means I'm going to replace x with?
9.
So anywhere I see x, I'm going to write?
9.
So what should I write here?
9 and 3.
9 and 3. Now, Kavita, let's compare some things. Over here, x was what? In this one, x was what? In the first example I gave you, x was what?
2.
Okay, in the second example, x was?
7.
And the third example, what was x?
9.
Alright. Katie, is x remaining the same or is it varying?
It's varying.
Therefore, we call it a?
Expression.
Well, that specific thing, we call it a variable. A variable. And these are the things that you'd find in our expression. So in our expression, you'd find numbers, variables, and an operation, like addition, subtraction, whatever. But Katie, can you see that the value for x is changing? It's varying.
Yes, sir.
So we call it a variable. That makes sense, right? If it's varying,
Yes.
it's a variable. Gavita, if you don't understand it, tell me, you know. Right? Tell me, is x changing?
Yeah.
Yes. So therefore, it's varying, and because it's varying, you'd call it a?
Variable.
Good. Let's look at the other term in the expression. So we looked at the x term. What's the other term in the expression?
Number.
The number. Kavita, what's the number in the expression?
3.
3. 3 is the number in the expression. Now, let's study the behavior of 3. Okay, we start off with 3. When I change the value for x, did that 3 change? Tell me, Gavita, did it change?
No.
Okay, when I put 9 instead, it changed?
No. The 3 remain all the same. It remains same in all equations.
Katie, you seen that too, right?
Yes, sir.
So if it's remaining the same, guess what you call it?
A number.
Yeah, but the proper way to say it is a constant. A constant. You know why? Because it remaining
The same.
constant. Yeah.
Oh, well, yeah.
Right. So cool. An expression is a combination of numbers, variables, and operations. So Gavita, when I say operation, you know what I'm talking about?
Yeah.
Yeah? That idea does sound very sure. Name some operations for me.
Oh, like direct the numbers and stuff.
Nah. But
Um,
it's using directed numbers.
like the positive and the negatives.
Yes. Alright, so operation, there are 4 main operations. 4 fundamental operations. Addition, subtraction, multiply, divide. Understand?
Yeah.
Right. These are operations. And so you could add 2 things. If you add 2 things, you would apply the adding operation on the 2 numbers. It could subtract two things, it could multiply two things, it could divide two things. So, Gavita, when I say operations, that's what I'm talking about. Positive, negative, subtraction, divide. Katie, you understand that?
Yes, sir.
Alright, so Gavita, let me show you what an expression looks like now. Fast. Example. So let's just say we have 4x plus 2y minus 9. First of all, Gavita, you see that equal sign anywhere over here?
No.
No. So if there's no equal sign, what do you call it? What do you call this? This whole thing.
An expression.
Right, this is an expression. Now something I didn't include here, right? But I should have included it. I should have included coefficients and constants. So the number part over here. So let me make it a bit more specific, right? A combination of constants, variables, operations, and coefficients. Do you know what a coefficient is? Yes or no?
One number in front the variable.
But do you know what it actually means though? Like, you actually know what it means?
Not really. I kind of confused.
Okay, no problem. Gavita, do you know what a coefficient really is?
Not really.
Not really? Okay. I like the fact that they tell them the honest thing. That's really good.
Oh wait, like if the coefficient for 4x would be 4.
You're getting hot. You're getting close, right? So I feel like all of us understand that this is an expression. Like there's no confusion, right? There's no confusion at all, right? Yeah, everybody okay with this? This is an expression. Let's look at the elements in the
Yeah.
expression now. So you're seeing a 4 in front of the x. You're probably saying, what does that mean? Well, it just tells us that in the equation, you have how much x's? How much x's you have?
1.
Nah, you don't have 1x. You have, say it with me, 4 x's.
4x.
And to make that make sense, look at this previous example. So Gavita, when you were reading this, right, and I asked you to come up with an equation, didn't you tell me 5x is equal to 30?
Yeah.
So Katie, when she told me 5x, didn't she, in her head, internalize that 5x means 5 apples?
Yes, sir.
Yeah, so the coefficient tells you the number of variables you have in an equation, of that variable you have in the equation. That's what it does. So if you see 4x, it tells you that there are how much x's?
4.
4.
4 x's. Actually, another way I could write 4x is x plus x plus x plus x. Wait, I can't count. Yeah, 4x. I understand that?
Yes, sir.
Yes, sir.
What's another way I could write 2y? If I write out the full thing.
Y.
Y add Y?
Y add y. Y plus y. Good. So do you all understand the number in front of the letter, which we'll look at just now, is the coefficient?
Yes.
Yes, sir.
Obviously, I'm not going to write out the full thing, but these are coefficients. Now, earlier, we named caveman era and thinking, I don't want to listen numbers. We better than that. When I ask Ollie what that is, Ollie not going to tell me numbers, right, Gavita? You're not going to tell me numbers. You're going to say the correct thing. You're going to say coefficient. Right? Yeah, Gavita, you're going to tell me the correct thing, right? You're not going to just say numbers.
Yes, sir.
Cool. And this x and this y. Now these two things are different, but you could use them interchangeably. Right? Unknowns and variables. these things are slightly different, but people use it interchangeably. So I'm just gonna pass slash, but there's a difference. But people use it interchangeably, especially in CSEC maths. And again, I'll put the difference over here. So difference. Okay, so Katie, when you hear the word unknown, what does it sound like?
Well, something you don't know, like, yeah, something you just don't know.
Okay, so there's something you don't know. If you don't know what something is, then your objective is to... What's your objective?
Is to figure out what it is.
Exactly, to figure out what it is. So, unknown is a fixed value that satisfies an equation. So it's a fixed value. So Gavita probably saying, you're probably scratching your head, be like, what? What do you mean by that? Let me explain. Gavita, if I tell you that, okay, I'm gonna write down this equation, right? Gavita, I'm gonna say x plus 2 is equal to 5. Gavita, what is the only thing you could add to 2 to get 5? What's the only thing you could add to 2 to get 5? Or what
3.
plus 2 is 5? So what's the answer for x?
3.
3. Could it be any other value for x?
No.
No. So would you say x could change, or would you say that x has to be 3?
X has to be 3.
Exactly. So if it has to be 3, is it changing or is it fixed?
It is fixed.
Right. So in this scenario, I'd say x here is a variable or unknown?
Unknown.
Yes, a unknown. And the answer for x is 3. Understand? Some of you with me?
Yeah.
Okay. Now, a variable. When you hear the word variable, what comes to mind? Variable.
Like something like, well, variable means like varying numbers.
Yeah. So, right. So let me give you a definition, right? So a variable is a symbol, right? So it's a symbol that acts like a placeholder. That acts as a placeholder. Do you know what a placeholder is?
Not really, like, it just any place for, like, anything.
Yeah, just any place, right? You could always replace it. Right, so a symbol that acts as a placeholder for a value that can change. That can change or vary. Alright, so let me give you all a good example of this. So Katie, let's just say that h is your height, right? H is your height. If we were to do a graph of your height of when you're now born to the height is now, would your height have remained the same or would it have changed?
It would change.
Exactly. So would you say height is a constant or variable?
A variable.
To be precise, is a continuous variable, not a discrete variable. But regardless, height you'd say is a variable, right? Because it changes. Gavita,
Yes, sir.
Gavita, you agree, right? And height would be something that changes. This is a variable.
Yes, sir.
All right.
Yes, sir.
Let me give you um a nicer mathematical example in case of a function. So I'm guessing you all don't know what a function is, right? Have you all ever seen that in your life? F of x. Ever? Have you all ever seen that?
Yeah.
Oh, you all have seen it.
Yeah.
Gavita, I guess if Katie saw it, you would have seen it as well.
Yes.
It can't, no, they could hide because like, um, if one of you learned something and the other one didn't, you could be able to say it in class if you did learn it. Uh, Kavita, you say that like, Katie, what do you mean? F of x? What? That's why you react just now. Is it that you forgot what f of x was or?
Yeah, but I think we did that quite big and enough form too.
Hmm. Worry, you'll be fine. Um. All right. Yeah. So, anyways, a function is like a machine. If you put something into the machine, obviously you'll get an output. Now, it depends on what you put into the machine. So, Gavita and Katie, you see how I just tell you a variable it acts like is a symbol that acts as a placeholder for a value that could change or vary. So you see how okay, so let me just call f the machine, right? And x is the placeholder, that's the input. Depending on what I put in that bracket, x will change. So let me give you an example. Let me give you an example, right? So give me a value for x, guys. Give me a value for x.
6.
Right. 6. And so Gavita, if I now replace x for 6, what is that gonna equal? Take a shot.
12x add 42.
You say 42. How come you say 42?
7 by 6 is
Oh,
42.
but wait. How do you get 7 by 6?
Because I think brackets means to multiply. So multiply them.
Oh, wait. Take your time, Gavita. Look at the function. It says, okay, so what does 2x mean? What does 2x mean?
2x,
I
2
mean,
open brackets, 6.
right, so 2x means 2 by x. And then you're seeing plus 7. When you look at this, Gavita, are you multiplying the 7 by anything?
No.
No, you're actually adding it to the result of 2x. So here what? You would say 2 by 6, and whatever you get for that, you'd add it to 7. So, Gavita, what's 2 by 6?
12.
And then I would say 12 plus,
7.
and then I would say,
That equals the 19.
19. Katie, is it that x has to be 6 or it could be equal to something else?
It could be equal to something else.
Right. What if it was... What if it was... Give me a value. Give me a value. Another value.
9.
I thought all it was going to say 7. I thought all it was going to say 7. Because you just found a 6.
Well, if you want to use 7, you can go ahead.
Okay. So Katie, if I put 7 into the function, right? So I replace x, and where's the name of x, Ollie? Where's the name of x? Somebody tell me, where's the name of x in this scenario?
A variable.
A variable.
Yes, because x is... What was happening to x?
It's varying.
Exactly, it varying, it changing. So x, oh my god, good notes, behave yourself. Alright. So this is our variable. These are this is what we call a variable. Remind me, what's the name for 2? 2 is the what?
Coefficient.
Kavita, you remember that? You figure that? 2. The name of 2.
I remember it.
Yeah, sure.
Yeah.
And the coefficient tells us the amount of what? Just tell us. So if I see 2x, it tells us that we have how much x's in the equation.
2.
2, that's all. That's literally it. If I tell you that x is now 7 instead of 6, what would that become, Kavita? What would I write?
Well, for your first statement, they could put the same statement with 2x add 7, and then they put another equal sign, 2 open bracket 7, add 7.
Am I going to multiply 7 by 7?
No,
No. What's 2 by 7?
14,
14 plus 7 is?
21.
Good, 21. Nice. So I think we understand the difference between our unknown and our variable. Do we or do we not?
We do.
We do.
Nice. Last thing I want to look at. By the way, you see how we have this positive and this negative? What do you call those? Positive and negative. Those are what?
Or operations.
Operations, yes. Those are operations. And the 9. Will the 9 ever change?
No.
No, the 9 will never change. It's a number. It's a constant. We call this a constant.
Constant.
Cool. Will this 5 here or this 2 here ever change? Tell me,
No.
guys. Both of these are what?
Constant.
Constant.
Exactly, constants. I'd say you all could take a screenshot of this. Did you all learn about domain and range and thing or no?
I think so.
Yeah, I think so.
Yeah.
So, okay. Alright, I'm gonna move on now. So I presume you all have that. Cool.
Yeah, we do.
So the main
Yeah.
purpose of algebra is to, in most instances, convert a real world scenario into an equation which you could solve an unknown. So if in this scenario we had 5 apples is equal to 30. Now when you're dealing with equations, right, there's some important things you need to consider. So we looked at expressions here. Let's deal with equations quickly. So do you all know what an equation is?
Yeah.
What's an equation? You can give
Yeah.
me a definition.
Like, okay. So I don't know how to define it, but I know like what equation is.
Alright, no problem. Well, I'll give you a mathematical statement, right? Right?
Okay.
So it's a statement asserting that 2 mathematical expressions. You see what I'm saying there? Read that part from I want you to read that part from what I just wrote on the screen. What did I just say?
A
A
statement that
statement asserting that two mathematical expressions are equal.
Exactly. So we're gonna combine two what? We're gonna combine two what?
Expressions.
Yeah, it has two mathematical expressions, and we're going to combine them together by putting a what sign?
A equal sign.
Good. Now I want you to think of an equation like a scale. So imagine if you was weighing chicken, or you was weighing something, and you want the scale to balance, and you would okay, so you know what scale does work on no?
Yeah.
Yeah.
Kavita is saying that kinda iffy. Alright, if I put chicken in this scale, what happens to the scale?
It
Is
will
that
be
where
up
chicken
on
would
one
drop?
side.
They go drop on one side. So we gotta add in this scale. In that
Well,
And
you
another
gotta
chicken.
you gotta add that chicken, right? So the point is, if an equation is like a scale, right, and you want the scale to be balanced, whatever you do on one side, you need to do on the
Other sign.
exactly. Whatever you do on one side, you need to do on the other side to keep equality. So, I put that in red. Whatever operation, remind me of the operations first. What are the operations?
Addition.
Addition, subtraction, division, and multiplication.
Cool. Whatever operation you perform on one side needs to be applied on the other side. And you're doing this so you go maintain what?
Balance.
Yes. Equality. See what I was looking for. Balance is correct. Maintain equality. You know, 2026 and all equality is very important if you know, you know. Right?
Yeah.
And let me give you an example of an equation. Suppose we had 4x plus 8. Now, by itself, what's 4x plus 8? The way it's written right now, what's 4x plus 8?
12.
No. Who said 12?
It's an
Me.
expression.
Wait, who said 12? Don't feel shame on saying we got correct it.
Gavita.
Gavita, you said 12?
Yeah.
Gavita, don't feel shame, you know. Don't feel shame. You're learning. Now, Gavita, I think what you're confusing this with, I think you're confusing that with 4 plus 8. I think that's what you're doing. But, Gavita, these two things are completely different. Let me explain why, Gavita. Do you know what x is? Gavita, do you know what x is? Remember,
X is
X is a placeholder, you know. X is a
yeah.
placeholder. X is a placeholder for a value. So you could replace a X for a value. So tell me, Gavita, as it stands right now, do we know what X is?
No.
No. So, here the thing, Gavita. I say it again. Do you know what X is? Katie, do you know what X is?
It's a variable.
Well, X is a variable, right? Cool. But do you know what the value for X is?
No.
No.
So, Gavita, if I ask you to multiply 4 by something, and I don't tell you what the something is, you think you could compute that for me? You think you could plug that into your calculator and give me an answer?
No. No.
It's only when I tell you what x is, you will be able to compute an answer. Like if I tell you x is 3, right? Then 4 by 3 is
12.
exactly. But if I leave you in the dark and I don't tell you what x is, you could do anything.
No.
No, I can't do anything. So you cannot compute this. You can't. How you gonna do 4x? So you can't say 4x plus 8 is 12. That's illegal. That's not legal. Gavita, if I tell you that x is 1 though, then you can do that. Because, work that for me now. If I tell you x is 1, what happen?
It just be 4 by 1, which is 4 itself again.
Right, and when you add it, you get 12. But do you understand that this and this is not the same thing?
Yeah.
Good, because can you actually compute 4x?
No.
No, you can't, because do you know what x is?
No.
You don't. So you cannot compute that. You need numbers to compute. So 4x plus 8, that's an expression by itself. And over here, I'm going to put on x minus 1. By itself, x minus 1 is a what? What's x minus 1? Anybody want to tell me?
Expression.
Yeah, that's an expression.
Okay.
Gavita, tell me why is that expression x minus 1?
Because it have no equal sign.
It don't have no equal sign. Exactly.
And it, yeah.
Now, Katie, what? And you know that pen and pineapple meme?
Yeah.
Right. I have a pen. I have pineapple. Boom. Pineapple pen. Okay, so like, what is it now? What is it? What do you call it now, Gavita? What's this now? What's that?
Equality?
Equation.
Equation.
Wait, equation. Sorry.
That's okay. That's alright. Equation. So, an equation is a combination of two expressions that are equal to each other. Right? So you have two expressions and they are what to each other?
Equal to each other.
Good. So I'm going to put on a big equal sign here, and that makes it an equation. So I have 4x plus 8, and that must be equal to x minus 1. Cool. Everything on the left of the equal side, of the equal sign, is called the what? What side is this? It's to the left of the equal sign. So what do you call that?
It have names for the different sides.
Yeah. But it's very straightforward, I promise. This is the left hand side. Literally, that's the proper name for it.
Oh, that's really easy.
Yeah. And this is on the right hand side. So we will call it the right hand side. I'm going over all of these things so meticulously because when we start to move with pace, right? I don't want to have to be explaining every minute what the left hand side is, what the right hand side is.
Yeah.
You know what I mean? All you need to know like
Yeah.
the fundamentals and all. So Gavita, when I refer to the left hand side, I'm talking about what's left of the equal sign. Understand?
Yeah.
When I talk about right hand side, I'm talking about what's right of the equal sign.
Yeah.
Now, for an equation to make sense, whatever is on the left must be equal to.
What's that on the right?
Right?
Cool. So in this scenario, would you say x is a variable or would you say it's an unknown?
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 Yeah. Do we know what x is?
No.
But I'm trying to find the value for x that would make what? Tell me, Gavita, that would make the.
It would make it known.
If you find it, it would become known, but what's the main objective here, Gavita? Like, what do you call this again? Remind me, what's the name for this? This is our what? This is
An
our what?
equation.
Right, this is an equation. And so the correct value for x would make this side what?
It would make it. Sorry, sir, I don't know.
No, think. That's okay if you don't know, just think. What sign it have in the middle?
Addition.
That's not what I mean. Like in the middle of the two expressions.
Oh, equal sign.
So the correct value for x will make the left hand side
Equal
equal to what? Remember, it's an equation. It had to be equal to something. Equal to what?
to the right hand side.
Yes! Thank God. Big up, big up, big up. So, in maths, when you solve an equation, you're looking for the value of x or y or whatever that would make the left hand side equal to the.
Right hand side.
And when that condition is met, the equation is satisfied. You're gonna hear me talking about that a lot, especially when we look at simultaneous equations. Please don't forget these things. So I'll write it in red so you don't forget. The point of an equation is such that it makes what? It makes the, tell me again, it makes the
Left hand side equal to the right hand side.
good. And Kavita, I'm saying Kavita, Katie, I don't know where I get Kavita from. And Katie, once the left hand side is equal to the right hand side, the equation is
Equal.
satisfied. It makes the equation satisfied. Because n is the whole definition of an equation, the left equal to the right.
Yes, sir.
So if it's satisfied, okay, if both of them equal, it's satisfied. So the point of an equation is to solve for the unknown such that it makes the left hand side equal to the right hand side. So I would say the correct value of x does what to the equation? Does what to the equation?
It will like bring it together because like if you know the value, you could then work out everything and get an answer.
A numerical answer, yes, but the correct value of x will make the left hand side equal to the right hand side because that's what it's supposed to do because it's an equation.
Well,
So
yeah.
the correct value of x, it'll make the left hand side equal to the right hand side, so it will satisfy the equation. So the correct value of x will satisfy the equation. And let me show you all exactly what I'm talking about. Alright, so Gavita, you ready?
Yeah.
Did you all learn how to solve for x in these types of equations or no?
Yeah.
Yeah.
Well, let me test your skills. So Katie, what's my first time?
You move the positive 8 to the right and move x to the left.
Yeah. Gavita, did you understand why she say what she say? Or not?
Yeah, all the x values had to be on one side.
Right, because we're trying to find for x. If I'm trying to find for x, then I want x to be the only thing there. So I could find for it, right? In other words, I want to make x the subject of the formula. So I want all the x terms on one side and all the constants on the other side, because we're using the correct vocabulary. In school, and you guys would have just learned us move it across, and move across.
Yeah.
Yeah.
Right. Let me show you what's happened behind the scenes. Wait. Let me just test something. What is the x term on the left hand side? Gavita, what's the x term on the left hand side?
the x term.
Yeah, what's the x term on the left hand side?
A coefficient, no. An unknown value.
This is an unknown value, but the x term is the 4x part. So, Gavita, can you see that we have our add sign here and we add in two terms, we add in 4x on it?
Yeah.
So 4x is one term and 8 is the other term. What's the mistake students make? They try to take away 4 and all kind of madness. No. Gavita, I need you to understand from now. This 4, it tells us the amount of x terms you have. So this 4 is part of the x term. So Gavita, if I ask you for the x term here, you're going to tell me x, or you're going to tell me 4x?
4x.
Right, so 4x is the x term on the left hand side. Katie, you understand that, right? 4x is the x term there. Good. So Gavita, we want to collect all the x terms on one side. So I say it again, Gavita, what's the x term on the left hand side?
4x.
What's the x term on the right hand side?
X.
Okay, cool. So we want all the x terms on the left hand side. That being said, Gavita, should the x term be here?
No. It
No,
have to shift.
So I would have to move it somehow. So when we're moving it, we're really getting rid of it from this side. So think, guys, think. If I wanted to get rid of x, what's the opposite of positive x?
Negative x.
Negative x.
So I would add a negative x on both sides. Tell me, why can't I just add a negative x over there? Remind me, why can't I do that? What we dealing with in this question? What do you call this? If I have an equal sign in the middle, what do you call that?
An equation.
Equation.
And an equation is sort of like a what? I'd give you an example.
Like a scale.
It's like a scale. If you do something on one side, you need to do it on the
Other side.
because you need to maintain equality. So if I take away an x here, I would have to take it away on the other side too. That makes sense?
Yeah.
Yeah.
Okay. And so when I do this, the x and the minus x will cancel off. And notice what's on the other side. Isn't minus x on the other side? So it would now become 4x minus x plus 8 is equal to minus 1. So that is what happens behind the scenes. That's why when you move it across, the sign changes. Because you had to take it away from both sides. So Gavita, let me see if you really understand this. So like I said, we want all the x terms to be on one side. Tell me, what's the imposter over there? Or who's the imposter?
8.
8. So we need to get rid of 8 from the left hand side. So what's the opposite of positive 8?
Negative 8.
So I would have to take away 8. That would get rid of it there, but I can't just do it over there. Where else would I have to do it?
By the negative 1 also.
Correct. The plus 8 and the negative 8 is going to cancel off. That leaves us with 4x minus x is equal to what?
Negative 1 minus 8.
Correct. And from here you could work it out. Understand?
Yes.
Alright, so that's what happens behind the scenes. So again, equality. If you do something on one side, please do it on the other side. In school you'll learn it like this. Pretty simple. You move across the x and you move across the 8. Didn't you guys all learn like that in school?
Yes, sir.
Yes, sir.
Alright, cool. But Katie, do you understand what happens behind the scenes where you want to get rid of it? So you do it on the other side, and that is why the sign has changed?
Yeah.
Yeah, sure.
Yeah.
Alright. So we're gonna move across our x. So you're gonna become 4x minus x. And when you move across the 8, it gets in minus 8. Tell me, Gavita, did I do anything here that just real loss here?
No, I understand.
Okay. if I have 4x's and I take away x, by the way, you're not seeing it right, but how much x's is this? Like 1, 2, 3, 4. What's the understood coefficient?
1?
1. Yes. 1. Because how much x's you see in here?
Just 1.
Just 1. So if you have 4x's and you take away a x, how much x's you have now?
3x.
Right, 3x's. And on the other side, we have minus 8 minus 1. So if you take 8 and you take 1 again, how much you take altogether? So Gavita, let me just say you take $8 from Katie, right? Katie, Gavita, this tax you.
No.
Money.
No, nah.
It's on in the other way around.
Probably.
Probably.
Alright. So let me just say Katie took $8 from Gavita. And then she take another dollar from Gavita. How much money you take from Gavita?
9?
9.
9. Since you take the money from Gavita, is it really yours?
Not really. No.
No. So you have to pay her back, right? Right? Right?
Yeah.
So it's negative 9 because you still had to pay her back, right? Think of negatives as owing people money. So if you see negative 8, negative 1, think of it like Katie taking $8 from you and then she taking another dollar from you. So altogether, she take $9. Since it's taken is 9. It's negative, so we negative 9. Are you understand that or no?
Yes.
Yes,
Sir.
sir.
Yes.
Katie, give back the girl she money, please.
Nah.
Next thing I see Gavita in High Street shaking a cup with coins. Because I Shiloh, I see you join real late, boy.
Yes, sir. My alarm didn't go off.
Hey, boy. Well, it better than me. My alarm went off and I was like, let me get out 5 minutes again. Lo and behold, I check the time is 8:50. I'm saying 8:50, 7:50. Yeah. But your mom wake you up or something? Because I had messaged your mom.
No, sir.
Next time I'll call your mom.
Yeah.
Alright. Your mom sleeping too?
Yes, sir.
Wait, boy. I understand. Alright. So here what? Gavita and Katie. We have 3 times x. Do you all understand how this means? 3 x's, right? That means 3 x's.
Yes.
Yeah.
Sir.
So I want to find for how much x's? 3 x's or 1 x?
1x.
Exactly. 1. So I need to do what on both sides to cancel off for this 3?
Divide by 3.
5.
Yes! That's smart. That's good. Then we divide by 3. Think about it. If we multiply an x by 3, right? And I want to get rid of the 3, and I will do the opposite. Think about it logically.
Yeah.
You multiply an x by 3. So if you divide it by 3, the 3 will cancel off. And that's the same thing you do in this apple question. Look at it. If I want to find for 1 apple, what am I going to do on both sides?
Divide by 5.
Divide by 5. Now when you compute this in your brain doesn't really do this. And your brain is just think, okay, Gavita, when I ask you the question, and it literally just tell me 30 divided by 5?
Yes, sir.
What happens to the other side? You see, your brain kind of advanced now. So your brain already knows that is for 1 apple, right?
Yes, sir.
But what actually happening is 5a divided by 5. So 5a divided by 5 is equal to 30 over 5. So therefore, 1 apple is equal to $6. Sheila, you know how much an apple is cost? 1 apple. Yeah or no?
No.
Hey boy. Somebody remind me to go in our school and do an apple sale. I will sell an apple for $12 and I'll make real money. Yeah. I'll compare with you and when I have a bazaar I'll sell apples. At $12 each. Alright, anyways.
Well, I know your tricks, so I won't buy any.
Damn it. I will use something else. I'll buy grapes or something. Alright, so the 3 and the 3 cancel off. And then we have negative 9 divided by 3. So we have a negative divided by a positive. So what sign will that result in?
Negative.
Negative, right? And so 3 into 9 is?
3.
Right, so x is equal to?
-3.
No. Let's backtrack. If this is a correct value for x, what it's supposed to do? I'm gonna see if I really understand all the madness we just did. Wait, Shiloh, I cannot catch your drift. I feel like Shiloh know the thing. He know the thing, right? I really want to test Gavita. I'm not really implying anything there, Gavita. I just want to bring out the beast in you know, Gavita. I want to make sure you understand the thing. So, Katie and Gavita, how would I know if x is equal to -3 is the correct answer? How I know
You
that?
take the equation 4x add 8 equals to -1, and wherever I see the x, replace it with -3.
Okay, and how I gonna know if that's the correct answer? What would tell me is the correct answer? I want to know. I'm looking for something specifically. How I know the answer correct? What will tell me the answer is correct? So Katie and Gavita, I promise you everything in the screen, and you understand the concept. You just had to dig around, figure it out. What will tell me if my answer is correct?
-3 minus 1.
Nah. Katie and Gavita, how would I know if my answer is correct? We trying to solve a what? What are we trying to solve? What's the name of this again? Wait, what's the name of this? Guys, what's the name of this?
Equation.
An equation.
What's the point of an equation? What's the main thing about an equation, guys? What we know about an equation? Let me get that straight.
To make whatever the whatever on the left hand side balance with whatever on the right hand side.
Yes.
Satisfy.
Yes. So Katie and Gavita, if I find x to be -3, how I could check if that's the correct answer? How I could check? Gavita, just say it enough.
Substitute your answer back to the equation.
And what will tell me if
Plug
I
in the
correct?
-3.
Right, but what will
Take
tell
an
me?
equation and plug it back.
Yes. Now, substitution is a very important part, right? But that's not answering it. Suppose I get something like, okay, like, let me just say I plug it in, and I see 7 is equal to 3. What does it mean? If you see something like 7 is equal to 3, what do I mean? That's good or that's bad? Katie and Gavita, if you plug in -3 and you get something like 7 is equal to 3, I think that's good or that bad?
Bye.
Katie, do you know why that's bad?
Because it's not equal.
Exactly, it's not equal. It's not equal. Is 7 equal to 3?
No.
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 So think. What will tell you if you're correct? So we know something like 7 is equal to 3 is wrong. But here, give me an example of an equation. With numbers. With numbers. Forget about the variables, the unknown. Just give me an equation in terms of numbers. Katie, give me an example. Just numbers.
8 plus 4 equal to, well, 12.
Yeah, that's correct. So when you simplify the left hand side, what is 8 plus 4? What's 8 plus 4? 12. So over here, what you notice? Tell me what you notice, Katie and Gavita. What you notice?
It equal
It
What
equals
what equal? What is equal?
both the left hand side and right hand side.
Yes. So when you plug in -3, what you're looking for?
For both sides to be equal after.
That is it. That is it. You're looking for both sides to be equal. And if both sides are equal, then that value for x will do what to the equation?
be equal to -3.
Nah, it will satisfy the equation. It would have satisfied the equation. Let me run it back again. So Katie and Gavita, when you solve an equation, you're looking for the value of x or y or whatever that would make what equal to what? You're looking for the value that would make the what equal to the what?
Left hand side equal to the right hand side.
And if that is the case, then that value does what to the equation, Gavita? What does it do to the equation if the left hand side is equal to the right hand side?
It satisfies it.
Good, please, please, etch that into your brains. Don't forget that. Please do not forget that. Right? So now is the time to see if we're correct. Are you trust any maths?
Yeah.
Die good talk, die good talk. Right? Let me see. Proof. Shiloh, I guess you knew that, right? That the left hand side had to be equal to the right hand side.
Yes, sir.
Alright, cool. So Katie, anywhere I see x, I'm going to write what?
-3.
Right. Kavita, am I going to say that this is minus... Wait, am I going to say 4 minus 3 is 1? What am I going to say?
4 multiplied by -3.
Good. A mistake some students make. Some students go write 1 in the next line, you know. You're laughing, but that could be you. That could be you. You never know. What am I going to write here, Kavita?
-3 minus 1.
Yeah, -3 minus 1. Earlier in class, I had said Kavita. I think I know why I say that. Because Katie and Kavita. I think that is like subconsciously, I think that's why I say it. You know, like,
Probably, yeah.
yeah. And so what's 4 by -3, Kavita?
-12.
Cool. So -12 plus 8. What's -3, -1, Katie?
-4.
Right. What's -12 plus 8?
-4.
Yes. Gavita, this is confused, yeah? Directed numbers here. This is confused, yeah?
No.
No? Okay. Well, if it does, yeah, well, imagine Katie take $12 from you. She take $12 from you, right? And she only pay you back 8. How much she still owing you?
You still owe me 4.
So it's -4 is the balance.
Yeah.
So -4 is equal to -4. Is that so? Answer my question. Was this the correct answer for x?
Yes.
Yes, sir.
Why, Gavita? Why was it the correct answer?
Because it balance off now.
Right. So it say the proper thing, right? So when x is equal to -3, it makes the
Left hand side equal to the right hand side and satisfies the equation.
absolute cinema. That's all I want to hear. Right? Good. Nice. So I'm happy. It sounds like you guys did a good bit of foundation already. Y'all did a good bit of foundation already. That's good to hear. Y'all think you could answer some questions?
sir.
Yes, sir.
Yes, sir.
I'll probably say a real baby, you know, Paulie, you know, but don't worry, I trolled into the ocean just now. But like I had to give Paulie, I had to real prepare Paulie before I troll into the ocean, if you know what I mean. Like I can't just, that would be kind of abusive if I just troll into the ocean without preparation. Yeah. Alright. Paste. No, I'm not done with the scenarios, eh? Again, if I come into my lessons, I really do just want a little learn the same thing I learn in school. I think I want a little go above average and like learn actually understand the thing. So let me give you an example, right? Of another scenario before I give you all some questions. But before I move on, absolutely everybody understands the difference between an expression and an equation as well as the name for each terms. Yeah or no?
Yeah.
Yes, sir.
Okay. Alright. Let me give a little example. If we have, so let me just say you buy something in a store, right? And what you buy in the store? Give me an example. Give me an example of something you buy in the store.
Chocolate.
Chocolate.
Yeah, a pack of chocolate.
I see. So let me just say you buy a chocolate and you get back some change. You get back $5 in change. And the cost of everything was, let me just say you buy an expensive chocolate, right? You buy a Hershey's chocolate. So let me just say, so let's try to interpret this equation. So Katie, it looked like you bought what? What did you buy with your money here?
5 chocolates.
No.
Oh,
Never buy 5 chocolate. You never buy 5 chocolate. You see enough 5 in front of this chocolate?
no. It's okay, wait. You buy chocolate and
But wait, how much chocolate I buy? You just seeing chocolate. It just seeing chocolate. It come like you're just seeing X. You're just seeing Y. How much chocolate?
1.
Right. If you don't see anything by it, it's understood to be 1. Okay? And it's the same thing with X or Y is 1. Right. So we have 1 chocolate. So you buy 1 chocolate, right? Gavita, if Katie buy a chocolate, that come like she paying you back? Or you wear your money back?
If she buying the chocolate, that means she want the money back.
No, hear what I'm saying, right? She taking money from you, right? If she buys you chocolate, is she on good terms with you or does she still have to pay you back the money?
She on good terms with me.
Or so she don't have to pay you back the money?
No.
Okay. Alright? Cool. So let me just say Katie buy 1 chocolate. Okay. Katie, what does the 20 represent? And again, we're thinking of like a context, like a scenario. So you buy 1 chocolate, right? And what do you think the 20 represents?
the price of the chocolate and 5.
Say that one more time.
The price of chocolate and 5.
Alright. I mean that's completely fair. The price of the chocolate plus the $5. Yeah. So this could be the amount of money that was in your wallet. Right?
Oh,
Think about it, Katie. You go into a store and you have $20 in your wallet. With me?
yeah.
If you spend the money on the chocolate, and you still have okay. So, and when you spend money on the chocolate, you lose that money.
Yes, sir.
That amount of money coming out from the 20, right? So that amount of money gone. And so when you add the amount for the chocolate and you add the $5 that remains, it must give you the original amount of money you walk into the store with. So you walk into the store with 20. So we can just say this was the total amount of money in your wallet, right? And that 5, what does that 5 represent?
Just 5.
Yeah, but what is it like? Okay, if you were to interpret it,
Um,
okay, so Katie, if I give the cashier $20, right, and the cashier give you back $5, what that
does it
represents?
change?
Right, this is the change. So if you give the cashier $20 and they give you back $5 change, and you can calculate the price of the chocolate,
Yes, sir.
what's the price of the chocolate?
15.
15. Easy, right?
Yeah.
But think about it at a greater level though. If chocolate plus an extra $5 is equal to 20, any chocolate could just be the 20 minus 5.
Yes, sir.
Gavita, think about this logically. Like, if you really don't understand, tell me, right? But Gavita, think about it logically for me. The chocolate plus an extra $5 is equal to what, Gavita?
The chocolate plus $5 is equal to the $20.
Right. And say if you wanted to find the chocolate by itself, and you need to take away the 5?
Yes, you have to take away the 20 minus the 5.
Exactly, because right now, this $20 is with the chocolate plus the extra $5. Do we care about the extra $5? If
No.
if you're trying to find the chocolate, you don't care about the $5. You want to get rid of it because you're trying to find for chocolate. So
Yeah.
when you are solving for equations and maths, you are reversing the process. I'm not sure if you see that, but you're reversing the process. Look at this again. Shiloh, Katie, and Gavita. Over here, I have chocolate plus 5. So to find for chocolate, we're going to do? We're going to do that 5.
Remove it.
You're going to remove it. You're going to... And how would you remove plus 5?
Minus 5 on both sides.
Exactly. So, Katie, can you see how minus and 5 is the reverse of adding 5?
Yes, sir.
So when you're trying to find for something, you actually come like a reverse on it. Yeah, you're just doing the reverse. So anyways, if I want to find for chocolate, so Katie, that 20 is the chocolate plus the $5. So the chocolate alone would just be 15. Now I have to remove the 5 from the 20. Yeah, so the chocolate. Now the reason I'm doing this exercise is because a lot of times when you hear algebra, you just get scared. And Gavita, you just get scared.
Over. Plenty.
Right, but I'm trying to show you you work with algebra all the time. You literally do. Like, okay, if I tell it, okay, here I'm going to tell you this scenario, right? So let me give a new scenario. So Shiloh, you there?
Yes, sir.
Right, so I went into a store, right? I buy a shaving cream. I'm real bushy. So I buy a shaving cream. The shaving cream costs $27, right? Yeah?
Yep.
I hand the cashier $30. Oh no, I'm not supposed to tell you the price of the scratch that again, another question. Let me just say you buy what are you buying in the grocery? What are you buying? Well, I know Kavita like chocolate. What about you, Sheila? What are you buying in the grocery?
A banana.
Okay. No problem. So I had $20 in my wallet. You buy a hand of bananas and the cashier give you $7 in change. How much was the bananas?
27.
Wait,
Oh,
wait.
wait, how much was the banana? Sorry.
I'm running back again.
Oh,
So you walk into a store, you buy bananas, you hand the cashier $30, right? You hand the cashier $30, and she give you back $5 in change. How much was the bananas?
25.
Gavita, you see how you just do algebra in your head? You see how Shiloh just do algebra in your head?
Yes, sir.
Right, so again, you walk into a store, you buy bananas. So Katie and Gavita, you buy a hand of bananas, and you give the cashier $20. Let me just say you get them $20, right? $20, and they gave you $5 in change. How much was the bananas?
$15.
Exactly. Gavita, you understand us or no? Be honest, be honest.
Yes, sir.
So Gavita, if I give somebody $20 and they give me $5 in change, how much the object would that cost?
$15.
Exactly. All that is algebra. I blabber enough. Let me do some questions. I got troll into the ocean one time. Let me do some paper one questions. Okay, let me see what you all are capable of at this point in time. Okay. Alright, so Gavita, give 20 when I read for me.
The sum of 7 times the number A and the number B may be written as A 7AB, B 49AB, C 7A plus B, and D 7 open brackets A at B close brackets.
Alright. Which one do you think is the answer?
C 7A at B.
Alright, that's your answer. Katie, what do you think is your answer? What do you think is your answer?
A.
Alright, so we have one for A, one for C. Sheila, you're the tiebreaker. Which one do you think is the answer?
Let's see.
O.
I think it's C as well. 3 to 1. Right, so Katie, let's read between the lines. So Katie, read back the question for me.
The sum of 7 times the number A and the number B
Waiter.
may be written.
So they're saying the sum. When you hear sum, what do you think?
Oh,
Sum. Sum means
to add, I was paying attention to A and the number B, so I thought 7AB.
we had to look at what happened in first. So they're saying the sum, right? The sum of 7 times the number A. Right? 7 times the number A. So what does that make A now? If they say 7 times the number A, that makes it what?
7A.
Exactly. And the number B. So the
And
answer is?
B. 7A plus B.
Right? Be really careful. Did you all do indices as yet?
Yeah.
Yep.
Well, I know Shiloh.
Yeah.
Shiloh, you sound like a boss in maths, you know. I feel like you like score really high in the maths and hard maths.
That's
Yeah, I feel like you here for kicks.
that's a
I feel. Anyways, the algebraic fraction, whatever that is, written in its simplest form is. So here what? The exponent, okay, before I even do that, I need to explain what happened in here. So, like, let's just say we had 5 to the power 7. We call 5 the base. 5 is the base. And 7, that's the exponent, that's the power, the index. All of that is the same thing. Good. The exponent or the power or the index, it tells us how much times we're multiplying the base by itself. So, like, if I had 5 to the power 3, what does that mean? Anybody?
5 by 5 by 5.
Kavita, you're confused by that or you understand?
I understand, sir.
Cool. So if you have something like 14 a squared, what does a squared mean? What does a squared mean?
A by A.
And Kavita, is in b squared, what do I mean?
B by B.
And in the denominator, you're seeing a cube. What does a cube mean?
A by A by A.
And then we see in by b, just by b, right? Just by b. I have a question. What power do you think is understood here? B to what power? Since it's b,
1.
1.
Kavita, you agree or not?
I agree.
I agree as well, because the power tells you how much time you're multiplying something by itself. If it's just b by itself, that's just b to the power 1. Logically, that makes sense. I have a question. What do you all think b to the power 0 is?
0.
1.
1.
1.
Yeah, it's 1. It's 1. Who's number 1?
Me.
Gavita, bad boy. How you know that's 1?
I learned in physics for the indices. I remember it.
Oh, I thought you knew the reason behind it.
Anything to the power of 0 is 1.
But you know why? You know why?
No.
I sure you don't know why. I can surely just know. But anyways, let me continue. So first things first, let's see if there's a number that could go into both 14 and 42. Is there any number that could go into 14 and 42?
Yes,
Yeah.
sir.
Yeah.
What number?
3.
Well, and
14.
you can use 14.
3 can't go into 14 and 42. I gotta be tired. Take that. Be careful. Careful. 14. 14 into 14 is,
1,
3. Oh, 4.
and 14 into 42 is.
3.
So immediately, any option, I think we could more or less see the answer is either between A or D, right? A or D. Because you're looking for answer with our coordinates. Are you understand what I'm saying or no?
Yes, sir.
Yes, sir.
Yes, sir.
And I'm definitely thinking it can't be D, right? It can't be D. That don't make any sense. Are you understand why I'm saying it can't be D or no?
Yeah, because you have to cancel off the variables.
Exactly. How you get a to the power 5, boy? How you gonna get a to the power 5? This would be the case if you're multiplying the bases, but we're dividing. Anyways, so Gavita, how much a's you have on top?
On top, you have 2 A's.
How much a's you have on it? Wait, those said 2 a's, right? You have, okay,
I mean,
you have the product of 2 a's. And on the bottom, you have the product of,
3 A's.
right. So 2 of the a's on top would cancel off with?
2 A's at the bottom.
Exactly. So let's look at this from an index perspective. So we had a squared divided by a cube. Now some of you all may not know this, but a cube is the same thing as a to the power minus 3. How much of you all knew that? Like if you have something in the denominator and you bring it up to the top, the sign for the power changes. Did any of you all know that?
Yeah.
Shiloh, you know that or no?
Oh, yes, sir.
Alright,
Yes, yes.
okay. Well, don't worry. I will show you like the easiest way to do it first. And Katie, when you look on top, right? How much base you have?
2.
And the bottom, how much b's you have?
1.
So we got one.
You'll just cancel off the b on the bottom and 1 on top, and remain with 1b on top.
So you're gonna remain with 1 over 3. Well, right, 1 over 3, cool. You have a 1 on top remaining, yeah. If you're confused about that, look, 1. We cancel off A, B, so what's the only thing that remains here?
b.
Where's 1 by B?
1b.
Which is B, right? If I ask you, where's 5 by 1? Where you tell me? 5 by 1.
5.
5. So where's 1 by B?
1b. Oh, b.
It's just B, right? Gavita, 1 here and B here. 1 by B is? Tell me, Gavita, what's 1 by B?
B.
Right, 1 by B is B. Cool, and in the bottom, 3 by A. What's 3 by
3A.
3A? Yeah, 3A. So, what's the answer?
A.
Cool. So you notice when you're dividing, do things combine or do they cancel off?
Cancel.
Katie and Gavita, when you're dividing, do they cancel off or do they combine?
They
Cancel
cancel
off.
off.
Okay. In terms of exponents, are you minusing the exponents or are you... Okay, that might be a complicated question. Let me give you a simple example and I'll explain. Say you had something like 5 to the power 3 all over 5 to the power 1. What does that mean? What does 5 to the power 3 mean?
5 by 5 by 5.
Are you confused all with me?
Only with, yeah.
And in a denominator, since it's just 5 to the power 1, what would that be?
Just
5.
5.
Just 5. Now think about this logically. You notice that the 5 in the denominator did what with the 5 on top? Earlier, the 5 in the bottom did what with the 5 on top?
Cancel.
Cancel off.
I can understand that, right?
Yes.
Okay.
So think about it. The 5, okay, so the 1, it took 1 from the 3, leaving us with how much 5s?
2.
Right, so 5 by 5 is 5 to what power? You have to say.
2.
Exactly. Now look at it again. Let it sink in. When you are dividing, the one in the bottom takes as much as it could from the one on top, and vice versa. So the powers actually subtract. Kavita, can you see that for yourself? Watch, 5 to the power 1 is 5. So this 5 here is 1 5 here would cancel off with 1 5 from the top, leaving us with how much 5s?
2 5s.
Good. So what I'm trying to say is, anytime you have the same base, so let me just say you had a to the power n all over a to the power c. What can happen to the powers? And if you're confused, look at what happened over here. What would you do with 3 and 1 to get 2?
Yeah.
So Katie, 2 is the same thing as what minus what? What? Toma, Katie. Katie?
Sorry. You could repeat?
So I want you to look at this example, and using this example, I want you to generalize the statement to this. So, Kitty, we had 5 to the power 3 divided by 5 to the power 1, and that gave us 5 to the power 2. So instead of doing this step, I could have just said 5 to the power 3 what?
Minus 5 to the power of 1. Oh, yeah.
What you just said was wrong, eh? It's actually in terms of the powers alone. So 5 to the power 3 minus 1. Because this 5 here is going to take away 1 from the 3. And you saw that for yourself over here. So anytime you have the same base and you're dividing, what happens to the powers?
You can use the same base and just put the powers right there.
Subtraction. Subtraction. Because when you divide, things cancel off. Okay?
Yeah.
And so something like 5 to the power 3 over 5 to the power 1 could just be written as 5 to the power 3 minus 1, which is 5 squared. Let me give you another example. If you had 5 to the power 7 over 5 to the power 2, what do you all think the answer would be immediately?
5 to the power 5.
Cool. So generally speaking, if I have the same base and I'm dividing, what do I do with the powers? Tell me, Gavita, what do I do with the powers? Do I add the powers? Do I subtract the powers? What do I do?
You subtract the powers.
Exactly. So if I have a to the power n all over a to the power c, then the general solution could be represented as a to what power? Gavita, promise it's simpler than you think, right? So look at this. If you were to do with 5 to the power 7 over 5 to the power 2, you would say 5 to what power?
5 to the power 5.
Right, and how you get that?
You subtract 7 minus 2.
Right. So I want you to, instead of using numbers, I want you to use letters this time to explain it to me. So that'll be a to what power?
A to the power, well, is n minus c, so
Yes, a to the power n minus c. So do you guys understand? If you have the same base and you're dividing, what do you do with the powers?
Subtract.
You subtract. Why? Because when you're dividing, things cancel off. Right. Are you sure you understand that?
Yes, sir.
So let me explain something quickly. If I have something like 5 to the power 0, tell me if this is wrong, right? Isn't 0 the same thing as 1 minus 1?
Yes, sir.
Gavita, Katie, Shiloh, 0. And 0 is the exact same thing as 1 minus 1.
yes, sir.
Gavita, you can see it, right? Where's 1 minus 1? 1 minus 1.
1 minus 1 is 1.
Exactly. Now, Gavita, I want you to use what you just learned. If you'd taken away powers, that would have meant there was division. So 5 to the power 1 minus 1 is actually what over what? I'm really making all think. Yeah, so Gavita, think.
It would be 5 to the power 1 over 5 to the negative 1 power.
Nah, look at it carefully. So a to the power n all over a to the power c, and that gives me a to the power n
Oh, yeah.
minus. So this
Yes,
could be 5 to the power 1 over 5 to what power?
There's 5 to the power 0.
Nah.
I mean 5 to the power 1 as well.
Yep, 5 to the power 1, because watch. It's 5 to the power 1 minus, so divide, power 1. And tell me guys, what's 5 to the power 1 over 5 to the power 1? 5 over 5, what's 5 over 5? What's 5 over 5?
5 to the power of 1 minus 1.
Wait, like just the numerical answer. What's 5 over 5? What's 5 over 5? Katie and Gavita, don't overthink it. Shiloh just said the answer, but ignore him. They're not about to do anything, but Katie and Gavita, 5 over 5 is?
1.
Yeah. So let we look at another example. Katie, 9 to the power 0. What is 9 to the power 0? That's the same thing as 9 to what power?
Just 1.
Well, 0 is the same thing as what? Say that again?
Minus 1.
Yeah, 1 minus 1 and 1 minus 1 is still 0.
Yeah.
And if you're using this rule over here, then 9 to the power 1 minus 1 is really what?
1.
9 to the power 1 all over 9 to the power 1, which we know is
1.
exactly. So the reason why anything to the power 0 is 1 is because it literally means you're dividing the same thing by itself. And that's what it means. So like if I had 7 to the power 0, that literally just means 7 over 7, which is 1. I feel like I don't really understand it.
No, I understand.
Sheila, you understand it or no?
I believe so, sir.
So, backtracking. Does everybody understand that when you have the same base and you're dividing, you take away the powers? Or you understand why? Like over here, you all understood why 5 to the power 2 was 5 to the power 3 minus 1.
Yes, sir.
And we generalize that. And I was saying, you know, if you have 5 to the power 0, that's the same thing as 5 to the power 1 minus 1.
Yeah.
And so 5 to the power 1 minus 1 is the same thing as 5 to the power 1 divided by 5 to the power 1. And that literally is 1. So that's why anything to the power 0 is literally 1. Because it like, okay, Gavita, if I had 10 to the power 0, that's the same thing as what over what?
10 over 10,
Exactly, which is
1.
because if you were to use the rules for indices, right? You have 10 to the power 1 divided by 10 to the power 1. And so when you have the same base, and you're dividing, you take away the powers. So that'll be 10 to the power 1 minus 1, which is 10 to the power 0, and we know that is 1. So I hope you understand a bit more now. That's why anything to the power 0 is literally 1. Anything to the power 0 is literally 1. Because it literally just means that like, itself over itself. But anyways, that's the answer there. Let's look at this question now. I'm going to show you all an extremely easy way to do this question, like extremely easy. So Katie, first of all, what do you call this? What's the name of this?
An equation.
An equation. What do you call everything on this side? Okay. That's only what? They call everything there.
The left-hand side.
That's the left hand side. And what was this? Kavita? What's this? That's 35. Tell me, Kavita, what's that?
The 35 is what on the right hand side?
Exactly. And Shiloh, we're looking for a value for x that would do what?
That would be equal to
That would
35.
that would make the left hand side equal to the right hand side, which is 35. Yeah.
Yes.
Right. All right. Okay. And so we know we want to get 35. And Katie, and do we want to get 35?
Yes, sir.
And we see over here we have 5 times this in brackets. Now I want to ask you all something. 5 by what would give me 35? 5 by what would give me 35?
7.
7.
Okay, so the correct value for x would make this bracket turn to what then? So I'll go over it again. 35, right? We want to get 35, and do you want to get 35? Yeah?
Yes, sir.
And then we have 5 times some big thing over here in brackets. Well, let me ask that question. 5 times what is 35?
7.
7.
Right. So that this whole big bracket It must be equal to what? What our whole bracket must be equal to?
7.
7,
That makes sense, right? Because what's 5 by 7?
35.
35.
Right, so that whole bracket there have to be 7. Are you with me, right?
Yes.
Yes,
Yes, sir.
sir.
Okay, cool. And so the question I'm trying to, what I'm really trying to pong into all your head, I'm trying to make all you think, right? Not just about dividing, multiplying, moving across, but like logically thinking. So the next question is, what what value for x would make that turn to 7? Let me think. So if
4.
we want to get 7, right, guys, if we want to get 7, what from 1 would give us 7? What minus 1 is 7?
8.
8.
8,
So then therefore 2x had to be equal to what? What 2x had to be equal to?
4.
8,
8.
8.
Oh,
And then okay, 2 by what is 8?
4.
4.
So you see, look, we get the answer. X is 4. Now if you're really good at it, you could do this like insanely fast. The answer is 4. So like, let me show you how fast you can do this in the exam. Alright, so Katie, let me run it, right? So Katie, we gotta get 35 ends. We gotta get 35?
Yes, sir.
5 by what is 35?
7.
So this whole thing had to be what? What our whole thing had to be?
7.
7, good. And okay, so ask yourself, what minus 1 is 7?
8.
Aha, 8, 8. So this 2x had to be 8. Okay, 2 by what is 8?
4.
4. Bam, get the answer. That take less than a minute. And now the other way you could work the question, there's actually two ways. Let me show you the other approaches you could take. And this will be the long approaches, of course. 5 by 2x minus 1 is equal to 35. The first thing you might probably do, you might probably divide both sides by 5. How much of you would have done this?
No, sir.
So maybe you would have done this. And if you do that, you're going to end up with 2x minus 1 is equal to what?
7.
7. Then you would do what?
Move across the -1 to the right.
And that would end up with 7 plus 1. And so 2x would be equal to 8. And then you would do what on both sides, Gavita?
divide by 2,
Yeah. Right? And so x is equal to what? 4. You could do that. But as, okay, so Gavita, Katie, and Shiloh, you see any steps we take here? That's the step. Okay, that is what went on in our brain when we did this approach. So instead of writing it out like this is what happened in our brain, and it was a lot more efficient. So I understand how this method and this method is the same thing. It's just like one you're writing out every step.
Yes, sir.
Yes, sir.
Alright, that's one way you could do it. The other way you could do it, you have something outside the bracket. So Gavita, anytime you have something outside the bracket, what you could do?
you can multiply.
Right, distribute. You can distribute. So I would distribute the 5 across all the terms inside the brackets. If I do that, what am I going to get, Gavita?
10x minus 5,
And that'll be equal to 35. What next?
you take 10x minus 5,
Say that again?
10x minus 5,
What do you mean by that?
what you mean no? Would you have to take the negative 5 and carry it to the other side?
Yep, you'd have to do that.
and it'll be equal to 35 plus 5, which equals to 40.
Right, and what next?
And then 40, well, 10 divided by 10 and 40 divided by 10.
So x is equal to.
4.
So these are all the different approaches you could have taken. But I think this is like the by far the most efficient one, like objectively. Yeah. Right? Cool. Before I go, I want to do this question, which I think might give all some real trouble. So let me call on the big guns. Shiloh, this question I read from her.
The sum of two numbers is 140. If one number is 10 less than 2 times the other, the two numbers are
Right. So the
50 and
sum.
90, 60 and 80.
Right. So Shiloh, what is in?
The sum of two numbers is 140.
At this point in time, do we know what the numbers are, Shiloh?
No, sir.
So maybe we could assign an unknown to it, a placeholder. Yeah. So we could probably just say the like one number is A and the other number is what?
B.
Yeah. So I could say A plus B is equal to.
C. Oh, 140, 140.
I don't understand that, right? Gavita and Katie, do we know what A and B is? It's two numbers you're dealing with. Do I know what they are?
No, sir.
No, sir.
No, but I know that they had to be equal to what? When I add them, they have.
140.
Right, I don't understand how I come up with that equation.
Yes, sir.
Yes, sir.
Right. Shiloh, let's read the next line. They're saying what?
If one number is 10 less 2 times the other, the two numbers are.
So they're saying one number, right? One number. So pick a number, A or B. Which one do you want to pick? Pick a number, A or B.
A.
A. So let me just say that A is 10 less than 2 times the other. So where's the other number?
B plus 10. I mean, minus.
Say that again. Where's the other number? If I pick in A, right? Where's the other number?
10.
Wait, so I have two numbers. I start off with A and B. Right?
A minus 10.
Wait, I take your time. So wait, give me a second. Right. So Shiloh, they're saying one number. So let me just say that one number is A, right? Let me just say that one number is A. Right, so one number is A. And they're saying that is 10 less than 2 times the other. So the other number, what we call the other number?
B.
Right, call her B. And so therefore A would be, so they're saying 10 less than 2 times the other. So where's 2 times B? How would I write 2B? 2 times B?
2B.
I would write 2B. And but it said that other number was 10 less than 2 times that. So that'll be 2B1.
Minus 10.
With 2B minus 10. You with me so far?
Yes, sir.
Right. Now Gavita and Katie, like we're into the deep waters now. This is the place where people just make real mistakes. Gavita, I think these are the types of questions that is like make you feel the vomit.
Sometimes.
Sometimes, so let me just go over everything I did so far. Because I think in a sense it's kind of straightforward. So Gavita, we start off with how much numbers? How much numbers?
We start off with two numbers.
Right? Alright, so two numbers, right? Do I know what the two numbers are?
No.
No, we don't know what the two numbers are, so what could call them?
You can call them unknown values.
We call them unknown values, right? So I call one A and I call one B. I wonder if you understand that.
Yes, sir.
Nice. Now, what I know about those two numbers? What do I know about those two numbers?
Is that one number is less than 2 times the other number.
But before that, what I know about them two numbers?
When you add them together, it will result to 140.
Right. Because it says sum, right?
Yes,
So do
sir.
you understand how I come up with the first equation?
Yes, sir.
Alright. Gavita, try to explain to me how I came up with the second equation.
So basically, you're trying to find out what A was. So then I put an equation stating A equals to, which was in the statement of the question, 2 times the other number. So it stated it equals to 2B minus 10 as stated in the question, which was one of the number is less than 2 times the other number, which is 2B minus 10.
Right. So that makes perfect sense for you, right?
Yeah.
Right, so Katie, Gavita, and Shiloh, all of us on the same page, or any of you are confused?
We on the same page.
Right.
Same page.
Now, this is a case of two unknowns. As you all are familiar, and wait, did you all do elimination and substitution as yet?
Yes, sir.
Katie and Gavita, did you all do the elimination or substitution method in solving a simultaneous equation?
Um,
Wait till again, I'll call the master. Yeah, guys, did you all learn elimination or substitution methods yet to solve a simultaneous equation with two unknowns?
Substitution.
Okay. Gavita and Katie, I guess not.
no.
Nah, that's not a problem. That's not a problem. I can show you how easy this is. Generally speaking, though, what do you all think is easier to solve? An equation with one unknown or an equation with two unknowns?
One unknown.
One unknown?
Exactly. Both of these equations have how much unknowns in them? Two. So in the substitution method, you are going to represent one variable in terms of the other one, or one unknown in terms of the other one, right? So like I say A is equal to 2B minus 10, right? So anywhere I see A, what I could write for A instead? Like instead of writing A, what I could write? Tell me Gavita, instead of writing A, what I could write instead of A?
X?
Nah. What is A equal to?
A is equal to 2B minus 10.
So Katie, instead of writing A, where you could write in place of A?
I don't know.
Nah, promise it right there. So Katie, A is equivalent to what?
2B minus 10.
Good. So Katie, instead of me writing A, what I could write instead of A?
2B minus 10.
Right, 2B minus 10, and that's what A equal to?
Yes, sir.
So instead of writing A, we could write in place of A. Let me give you a good example, right? Let me just say I have $100 bill, right? $100 bill. You want more?
Yes, sir.
And okay, how much $20 bills you go take to make 100?
5.
Right. So instead of using $100, how much $20 bills you could use?
5.
Right. So instead of using E, we could use instead of E. What is A also equal to? So let me go back to this
1.
example. Instead of having $100 in your wallet, we can have instead, but also still be equal to 100.
20s. 520.
Exactly. Exactly. So instead, if something costs $100, and you could just get them the 520s because that's still equal to 100. Equal to 100.
Yes, sir.
Okay, it's the same thing here, I promise you. So what is A equal to? Well, okay, equal means that it is like literally the same thing.
Oh,
What's A equal to?
140.
Nah, A is not equal to 140. A plus B is equal to 140. But what is A equal to? I feel like you're overthinking it, like you're right there in front of you, I promise. What is A equal to? You tell me several times. Right. So, Katie, A is equal to what?
1.
Nah, A was equal to 2B minus 10.
Oh.
You see, for yourself, right? What's the
Oh,
name
yeah.
of that symbol? What's the name of that symbol?
Equal sign.
Exactly. So A is equal to,
2b minus 10.
yes. So that means A is equivalent to what? Like instead of using A, what could use instead? That means the same thing as A.
2b minus 10.
Exactly. Katie, I know it's sounding weird, right? But 2B minus 10 means the same thing as A. Like
Oh,
you feel like you could understand that like look like both of them literally what to each other. Like both of them literally what to each other.
equal.
They're equal to each other. So you know what? Instead of using A, we could use instead.
2b minus 10.
Exactly. Probably saying how they're gonna help you. Katie, would you rather solve for one unknown or two unknowns?
1.
Exactly. So what we could do is instead of using A in the first equation, I could replace A with what?
2b minus 10.
2B minus 10. Exactly. And you just come up with the substitution method for solving simultaneous equations. Right? But anyways, you're gonna plug this here, and so that's gonna become what now?
2b minus 10 plus b equal to 140.
How much unknowns you have here now?
1.
One, just B, right? So let's look for like terms. What like terms are you seeing here?
b 2b plus b
Which is
3b.
and then I have minus 10 here. Why should do the minus 10?
Carry it across to the right hand side and you'll get 140 plus 10, which is 150.
Make sense?
Yes,
So one of the numbers, which hey, we just find for one of the numbers. One of the numbers is
50.
so where's the only answer that makes sense?
E.
A. Now, Katie, you just found for B, but is there any equation telling you what A is in terms of B? Tell me, Katie, is there any equation telling you what A is in terms of B?
Yeah.
Which equation?
A is equal to 2b minus 10.
Exactly. So B is 50. So 2 by 50 is 100, and 100 minus 10 is?
90.
Ah. Now, isn't that the first answer?
Yes, sir.
Alright, so Katie, I would have just introduced you to simultaneous equations. So let me run over the concept again. Katie, would you rather solve for one unknown or two unknowns? What would you rather do?
1.
One. Now, the first thing you have to do is come up with two equations. Does everybody in class understand how we came up with the two equations?
Yes, sir.
Shiloh and Gavita. Gavita, I feel like I'm leaving you. You and Shiloh. Shiloh and Gavita, are you okay?
Yes, sir.
Yes, sir.
Right. So cool. Now this equation have two unknowns and this have two unknowns. So, Katie, notice that the second equation tells us what A is in terms of what?
B.
Exactly. Exactly. So instead of writing E, what could I write for A instead since it's equal?
2b minus 10.
You understand how that gets rid of the using the variable, I mean the unknown A, right?
Yes, sir.
And it allows you to make an equation solely in terms of
Getting rid of 1.
so it allowed you to make an equation entirely in terms of what? In terms of what
B.
unknown? B, yes, yes. And that's something you could have solved for, right? Good. I feel like you're understanding something now.
Yeah, I understand.
So with the substitution method, you're gonna take one of the equations, make either A or B or whatever the unknown is the subject of the formula, and you plug in that into the other equation. Why? So you only have one unknown to deal with. In the next class, I'll give you all the homework. I'll give you the homework.
Yes, sir.
Yes, sir.
Yes,
So,
sir.
yes, okay. He said, hey, hey, I gotta talk to Mrs. Kim.
I do.
Right? Okay. So I'm a bit hesitant. Alright, so Gavita and Shiloh, let me make sure they understand anything. So Shiloh, you understand that had two unknowns in both equations, right?
Yes, sir.
I can't really do much there. However, this equation is telling me what A is in terms of B. Seeing that?
Yes, sir.
So instead of writing A, what I could write for A instead?
2b minus 10.
Why? How I could do that? Why allowing me to do that?
Because in the other equation, it says that A is equal to 2b minus 10.
Exactly, and aren't they equal?
Yep.
If they are equal, and I could use them in place of each other.
Yes, sir.
Like the example with the $100, and five $20 bills could be used in place of a single $100 bill.
Yep.
Exactly, it makes sense. And we're doing this so we're gonna end up with an equation in terms of one unknown. Because I can't deal with two. I can't do that. So you understand?
Yep.
Nice. Gavita, let me talk. Gavita, how we feeling? Like on a scale of 1 to 10, like we feel like this?
Yeah, understanding it.
So you feeling like that or you feeling like this? You feeling?
I feeling like the second one. I feeling good.
That's good. I'll sing this song there. You know, like the meme? Let me know. You know how it does go? Like, I can't sing on it. I can't sing. How does it go again?
No, you should sing.
Say it, Katie. I feel like Katie could sing or not. I feel like Katie could sing.
No, I don't.
I feel so too.
I was actually singing a lot in school for my friends.
That is why I'm saying. I know that. I talk to Gavita. Gavita tell me them thing. Gavita bust your files. Right? Alright. Yeah. Give me a moment. Yeah, I have a physics class just now. Shiloh, I have a class with you just now.
Listen.
Like literally, like now. It's supposed to be now.
Yeah.
Right? So I will wrap this up. I will send you recording and thing, but maths people, or they could leave. I will send homework. But yeah, guys, take care. Much love. Have a good day.
Bye.
Okay.
Ah, all right, stop.